Introduction to Neural Networks with Java, Class 11, Part 2. Welcome to Part 2. In this part, we're going to learn how to actually run the program that attempts to predict the S&P 500. This program has several modes that it can operate in. This is the most complex neural network that we've looked at in this class so far, and it can train for any amount of time that you set it for. From a few minutes just to test things, up to several hours or even several days for a more advanced, lower error rate neural network. Because you invest so much time in training such a neural network, you need to be able to save it. And the program allows you to do that. The program can run in several modes. It can create the data sets for training. It can actually do the training. And then when it's done training, it can actually evaluate how well the network is capable of predicting the S&P 500. We will see how to run it in each of these modes, and we'll see what files it requires. Because this program uses external data, it needs this data. The book provided you with data for the S&P 500 up to the date of printing for the book, as well as the prime interest rates for this same amount of time. The neural network will use these as input data to look for trends and attempt to predict the direction of the S&P 500. We will now look at how to run the program in these various modes. Here you see the configuration information for the S&P 500 prediction program. This data is contained at the top of the Predict SP 500 class file. This data is used to configure certain options that allow you to change the way that the S&P 500 prediction program runs. The first one is the training set size. Here I have it set to 500, which is a reasonable value. However, a larger value would give it more data and perhaps allow it to find a better way to predict trends in the S&P 500. A larger value than this, however, would take longer to train. A smaller value would train faster, but it would not give as precise of predictions. The input size specifies how many input neurons we're going to use. If we specify an input size of 10, that means that we are going to use a trailing 10 S&P 500 financial values, the current location of the S&P 500, and we're going to use 10 values from the prime interest rate. Now these values that we actually pass into the neural network are percents. We feed the neural network the percent changes that occurred over these 10 periods, and it should then predict the percent change for the 11th period that occurs after this. 10 is a reasonable number. It's over a week. You may want to feed a larger value, maybe have it predict over the course of a month. However, this is going to cause the neural network to train slower if you increase the size of the input window. Also, if you make the input window too big, there's not going to be enough to really predict a pattern. If it's a year, then you're going to need an entire year of stock prices to be the same in order for it to predict the next value. So you need to kind of experiment with these and see what's going to work the best. The output size is 1 because we're simply predicting one period into the future. We also allow you to specify the size of the hidden neurons, layer 1 and layer 2. We're currently not using a second layer, and we're using 20 neurons in the first hidden layer. Again, these you want to experiment with or use some sort of pruning algorithm to determine an optimal value. The max error is how acceptable of an error we're willing to take. We're willing to take 2% here. We also specify a date that we want to predict from. After we're done training, the neural network is going to use this predict from date to start doing its predictions. The next date specifies where we want to learn from. The neural network will begin generating training set data from this date. You don't want these two dates to overlap because you want the neural network to be trained on different data than it is actually evaluated with. There are essentially two modes that this program can be ran in. If you specify full training, then the neural network is going to attempt to completely train the neural network before it actually evaluates. Now at the end, it's going to save this file to the neural network to a serialized file so that it can be restored later. However, if you specify full training, the program is going to execute a complete training cycle, and it could take a while. It could take anywhere from a few hours to a few days, depending on how you've set up the configuration data. The book comes with an example neural network that I trained for several days. Evaluate only, the other form of running this program, specifies that the neural network should simply load it and run the evaluation only and not train. To run in full mode, you specify full as the first command line parameter. Here you see the run method. This run method is called by the main method, and a Boolean is passed in to specify if we are doing full training or not. You can see that we create a new S&P 500 actual object. This we're going to look at in the next class part when we see how the program actually generates the actual data, and we load the S&P 500 from the CSV file and the prime rate from another CSV file. We display the number of samples read. If we're doing a full training run, then we need to create a neural network, which will create a neural network with the specified number of hidden layers and neurons and input and output specified by the configuration file. And we will then generate the training sets. We'll generate the training sets based on the data that we actually loaded up higher when we loaded the S&P 500 CSV and the prime data CSV. We then execute the training procedure. This is done by the train network backprop. This does a hybrid training algorithm that we will see later in this class session. It uses backpropagation primarily, however it will kick in simulated annealing in the event that a local minimum appears to have been reached. Once we've trained the neural network, then we save it. This uses regular serialization, and the file can be read back in when the program is later executed. If we're not running a full, the else that you see there, we load the neural network from the file that was generated on a previous run, or maybe you would use the file that was provided by the book, where I trained it for a few days before releasing it. Finally, display is called, which actually evaluates the neural network. We'll see this later in this class session. This concludes part 2. In part 3, you're going to see how we generate the actual data that is sent into the neural network for training. We need to be able to stitch the separate data sets of the prime interest rate and the S&P 500 historical data into a single training set. We will see how to do this in part 3. I hope you will continue with part 3. Thank you. This course is based on our Introduction to Neural Network Programming books for Java and also Introduction to Neural Networks for C#. Available in both paperback and ebook format.